Hello, I need to share my screen. So we're on to this class on rearranging formally, rearranging equations. Okay, so you can see my screen. Yeah, my voice is up. I'm Laura Lewis, and welcome to the class. Okay, so we're going to look at rearranging equations today. So I've got here the GCSE Sciences Physics equations to learn. Okay, so to learn, so going to learn these. Okay, so this is why I picked on these. And to learn them. So it seems like I can show you the whole thing. This HT means higher tier, so the higher tier paper. You'd only see that in. There's a few things to learn. It seems like more than it really is. Okay. So we'll start. So we'll start with some equations to do with free variables. Let's have a look. So this is the one you see a lot. So forces, mass, time, acceleration. So this is Newton's second law. I'm going to put a new whiteboard up. We're going to look at this equation. Okay, so some of you may notice, well, hopefully you should know it, but you will learn it as Newton's second law if you don't know it yet. So Newton's second law, and it's actually got a formula that it can be shortened into. Newton's second law. Okay, got two other laws. So F equals very nice, friendly equation used a lot in physics. Sometimes that you can write things together like F equals ma. I know it as. It might be easy to remember it this way. And having to remember that times, because if you write numbers together, they mean times anyway. Okay, and it does matter as well. I get asked this a lot. It does matter the upper or lower case of them. Physics, it does matter. A small f can mean something different to a capital F or a big F. Big M means something different as well, and a big A means something different as well. So the case matters here. Okay, so it's very, very much like maths. A lot of people can rearrange things in maths. When they get to physics, they start having a bit of a worry that it's different, but it's exactly the same. So I said to people, if I told you, you've got this equation F equals ma, and someone said to you, make A the subject, like in a maths paper. Okay, that's how it would be phrased in a maths paper, because I'm looking at maths papers, and I know that's how they phrase them. Okay, I've also taught A-level maths as well. Make A the subject. So what people do, always write out the equation again. I always do that. That arrow that was equals an arrow means carries on from. Maths you have to worry about it means carries on from. I just write it a lot. Okay, I need to say, okay, so I want A on its own. What I'm really doing is dividing both sides. So as long as you can do anything to the equation, as long as you do the same thing to both sides, you can divide, you can times, you can do anything. Okay, and it seems sort of a bit crazy first of all. With some things, as long as you do it to one side, you can do it to the other, you can do it. Okay, so you divide both sides by m. Okay, so you divide both sides by m, you get f over m equals, and because m is multiplied by a, okay, you'll get a on its own because you divided by m. M is now gone. Okay, so just in case it's the first equation, I'll show you how I might write it if I wasn't going to divide like that. So I would go f over m. So you could say f divided by m. If you're writing out like that, okay, it always makes a noise. Okay, cancels. They cancel each other out would be the term for that. Okay, equals a. Okay, and it's the same, isn't it? It's the same thing. Okay, so let's think about a question you may get on this. New whiteboard. Okay. So yeah, that's fine. Let's have a question on this. Yeah, it's very common. So let's have a different one. Anyway, so a trolley. So that you have in the supermarket. A trolley with a mass. They're quite heavy, aren't they? 50 kilograms. I'll try and make it so I have to use any calculators in this class, but I won't promise. Is pushed. Very common physics question. Could be a truck, could be anything someone's pushing, or yes, it'd be a boat being pulled. I've seen all kinds of the same question though. With a force. Remember, force is always newtons. Okay, of 100 newtons. Okay, what is the acceleration? Okay, So acceleration on those words, it's quite hard to spell, I always think. So don't worry, I should spell it correctly. I've looked at it and gone, before. Okay, again, it's not really a spelling test, it's physics. Okay, so F equals MA. M times A or MA. Okay, let's put numbers in. You can either rearrange it first or put numbers in first. I actually tend to put numbers in first. And lots of students seem to like me doing that because you kind of see where you are. But you can rearrange first, like you do in maths. They are both equal to each other. So 100 newtons equals mass 50. Sometimes with simple equations you can see the answer, but we'll go through the proper motion with you. Okay, times A. So divide both sides by 50 kilograms. In this case, so dividing by the number, which is, so yeah, sometimes it helps to see numbers in it. I mean, this is the way I always used to like doing it. It's why I kind of like showing it to students. We can rearrange first. I might get some examples. Okay, and we can work that 100 divided by 50. So 150 is going to it's 2. So 2 equals A. Okay, let's just go down a look because I can obviously write out properly. I can do that. Fancy. Okay, so generally write the letter equals something, don't we? That's just a convention. Okay. Oh, I somehow changed my pen. Okay. Right. A equals 2. And let's think about the units here. Acceleration is measured in meters per second squared. That's the units of acceleration. Show we finished, underline it twice like that. Because the person marking your work showing that you finished here. Because the person that marks an exam will look for the answer. Okay, if you get the answer right, you usually get 4 points. But what happens if you somehow put something into a calculator wrong, which happens sometimes, if you've got some of the working right, you get marks for the working. Always show you get marks for writing an equation. If it's one of these equations you have to remember, you actually get marks for writing the equation. Okay, so 1 easy mark, another easy mark for working. Even if you don't get the answer entirely correct, it's still 2 out of 3. Okay, so physics is nice like that, where you can actually just get marks even if you didn't get the answer right. Okay, so it's just putting the thing to a calculator. Everyone does it in the exams. I've done it and gone back and go, oh, but yeah, you get 2 out of 3. So yeah, it's just a error carried forward, if that's actually called. Okay, so let's look at another equation. There's lots of equations. Okay, weight, another very common one. We're looking at just 3 variables at the moment. Weight is mass times gravitational field strength. You may not have looked at it like that before. Let's get a new slide. We can have infinite slides, infinite room. Okay, so blue. Okay, so weight. So someone's weight on Earth, okay, is determined on their mass and gravitational field strength. Apologise, there's noise in the background. It might be a train going past, like the train horn. It's certain weather conditions, you can hear the train. There's a bit of physics going on there. About the pressure and high atmospheric pressure, you can hear certain things. Okay, so weight. Weight is in newtons. Weight is actually a force. Mass is always in kilograms. Okay, gravitational field strength, don't have to worry about the unit at this level. Okay, so, but it is 10 on Earth, okay? Because this depends on what planet you're on. We're mainly on Earth, so let's state otherwise. But we can talk about that. So it's supposed to be an arrow. Okay, by the way, I'm a bit wrong. Okay. Wait, so if let's have it. Let's shorten it first. W equals mg. Who should that shorten to? Again, small m for mass. G gravitational field strength is small g. Big G something different, so you got to be careful. Okay, so let's go straight into an example then. So if a box of chocolates, this is one of those big ones you get at Christmas. Chocolates has a mass of 5 kilograms. I actually have got one that had a mass of 5 kilograms. People saying, don't believe me, I had one that big. There was a special edition Quality Street. Had a mass of 5 kilograms. It has 5 kilograms. If a box as its mass, my English is not very good there. As its mass, what is its weight on Earth? is its weight. I mean, for this one, you don't have to rearrange at all, do you? But I'm sort of showing you what sort of answer we're going to get from this. Mass, 5 kilograms times 10, easy enough, 50. W equals 50 newtons. We are finished there, so let's have a rearrangement. Okay. So let's think if, oh, my pen's gone. So if an object had a weight of 100 newtons, what is its mass? It's one of those ones that you have to work out, but again, we'll go through the whole thing. Oh, let's move everything up. Okay, so if that was a question in real paper, always write out what you're doing, even though you think, okay, this is easy, you still have to write out and say what you're doing. So W equals mg, show the person you understand. Okay, weight, so 100 newtons equals mass, don't know, times 10. So rearrange and divide both sides by 10. So 100 newtons over 10 is equal to m. We can quickly work out that that's going to be 10. So m equals 10 kilograms. That's very straightforward, isn't it? Weight and mass, things like that, they're quite straightforward. You won't really come across that many things that are that difficult associated with it. Let's have a look at it. Let's look at more challenging equations, shall we? Let's look at the energy ones. These come for a lot. Okay. A lot. So we've got GPE and kinetic energy. So we'll look at these two. Let's have a new whiteboard. Right, gravitational potential energy. I've seen this a lot in exams. Okay, so gravitational potential energy, or GPE. Gravitational potential energy. Okay. So GPE. Yeah, you get if you keep writing, you get bored right now. So it equals mg delta h on it. So it's mass times gravitational field strength from before. Field strength. I'll keep sort of switching it onto that. Good. Just do that to make sure it's working. Strength times a change in height. Okay, so that what this is the change in the energy store when you lift something up against gravity. So if you put the box above the floor, you're actually increasing its store of gravitational potential energy. So the higher an object is, the away from the Earth's surface, the greater its gravitational potential energy. So change in height. Okay, this is there's an easy way of writing this down. Mg delta. That means a change in. That's a Greek letter delta. Okay. Delta. So change in. Mg delta h. So example, e.g. It's always good to have an example, isn't it? So an object of mass 2 kilograms, so smaller box chocolates, still quite big though, 3 biscuits, something, is lifted. I did see a 1 kilogram box biscuits yesterday, so just 2 of those. It's lifted above the ground. By 3 meters. Okay, I put on a big shelf in a factory or something. Okay, what is the change? and gravitational potential energy. In GPE. Yeah, that's gravitational potential energy. Let's go move this down. So just putting numbers in at the moment. So GPE equals mg delta H. So mass 2 kilograms. G on Earth, remember it to be 10. Delta H 3 meters. 2 times 10 is 20. Times 3 is 60. So 60. This isn't energy, so it's joules. Okay, joules. I'm going to write that, but it's J just for joules. Okay. So let's have a question. Another question on that. Go down a bit. So let's have a new question here. We've got infinite space. So an object. So object has a change of GPE of let's have a think, 200 joules. The object was lifted was lifted 5 meters. What is its mass? Okay, always write the equation out, as we know you get a point for that. A mark, a point. That's like a better game. A point or a mark. Yeah, a mark. Okay, mg delta H. The GPE we know this time. So I'm a bit of a slant here, aren't I? I'll try and write it more straight. I write on a graphics tablet, so I'm kind of writing on a slant. Okay, GPE, so 200 joules. Yeah, try and be a bit straighter my writing. Equals, we don't know that. M stays the same. G is 10. We've already asked to find G because we can't know what it is. No. Okay. Times delta H, 5. Okay. So what we would do here, we'd multiply something out a little bit. Okay. So that's what I would do. So 200. Okay. M times 10 times 5 is 50. So we've got more than 3 variables, but it's kind of going down to the same thing, isn't it? Okay, divide both sides by 50 to get M on its own. Let's go down a bit further. Right, looks quite big. That's okay, you can see it. Okay, so how many 50s go to 4? Okay, so no, it's not meters, that's mass. Yeah, so yeah, it's easy to get confused. So 200 divided by 50. Okay, it's going to be 4. So M equals 4 kilograms. Okay, that's an example of that question. So, we've done a few different things there. Maybe just do one. We'll do kinetic energy. Let's do kinetic energy. Another one you have to learn. So, kinetic energy. Okay, this is the one with half mv squared. Half times mass times velocity squared. Yeah, it's not actually that hard to write out that, is it? Okay, and this is the one where I always write KE. You can use this a lot. Kinetic energy. Half is just a number. Half or 0.5. I'm going to write out this for this one. It's got a squared in it. Okay, so kinetic energy is the energy of moving objects. So if an So I think if an object, we'll go for an object, is moving at 5 meters per second. So this is how you write it for velocity, and has, what about A there, has a mass of 2 kilograms. What is the kinetic energy? What is its kinetic energy? So the one belongs to it. Okay, so so again, substituting numbers, that's all. Okay, so KE that's 0.5 into a calculator. In what half? Times mass 2 times v squared. That's 25. So write it out. Half of them is gonna see half out. 2 times 25 is 50. Guess it's 25. 5 is 25. KE equals 25 joules. Okay, so it's easy as that. Put numbers in. Let's see if I can get a question. So we have a bit of an advanced one. So if an object has a kinetic energy KE of 500 joules, comma, and a mass of 10 kilograms, what is its speed? What is velocity? It's a bit more complicated one. Okay, right, so let's write the question out. KE equals half mv squared. So since we know 500 joules equals a half, you can write as 0. I'm going to write as 0.5 because it's exactly the same. Mass, we know. Don't know its speed. Interesting. Okay. Yeah, most interesting thing so far. In terms of rearranging, anyway. Right. Okay. So do a few things. So I'll do this way. 500 joules. So 0.5 times 10. So you multiply by 0.5, just divide by 2. So it's just 5. 5 times v squared. Right. We're going to divide both sides by 5. 500 divided by 5. My 5's like S is got a lot, don't they? Okay, and we know that this is going to be 100. It's just numbers. Okay, so 500 divided by 100 equals v squared. Okay, then we take square root of both sides. Okay, so if you know how to do this properly, you can do any equation in the world. Not lying at all. You can do any equation in the world. You can do this. Rearrange equations of both sides. How you'd write that, I know you probably can't see the answer here, but how you would show that is square root sign, like we have in maths, is equal to v. Okay, and the square root of 100 is 10. Okay, sometimes it might not be as obvious as this, you might need a calculator, but that's still fine. So that's going to be square root of 100 is 10, so v is 10. And that was the speed or velocity. Okay, so that's the end of this class for now. Hope you've enjoyed it and learned a few things. I hope to see you in another class. But that's all for now, and thank you and goodbye.